Yeah, welcome back to today's class. Unlike C program or some other programming languages, a Python variable does not need an explicit declaration to reserve memory space for it. The moment you assign a value to a variable in Python, it automatically created. But like in the case of C, you have to explicitly declare the variable, right? And the data type before you can now assign a value to it. What I mean by that is in Python, you can just simply say, like what we did in our last class, here we say A equals to 10, right? This was what we said, A equals to 10. And then if you just click on it, it's already assigned, meaning A is now having 10 in it. So this is, the moment you assign this 10 to this A, automatically a memory space is created. You don't have to explicitly declare a variable. Like in C language, you first and foremost, you will have to say, you have to define int, then you say A, and then you put this. This is how you will have typed it in C, right? Before you now come and declare, before you now come and say A equals to 10. If you don't declare it this way in C, this is how you will have done it in C. If you don't declare it, you cannot come and assign 10 to it. But in Python, it is not done that way. In Python, this is how it is. The moment you assign a value to the variable, it is automatically created in memory. Memory is automatically allocated to it. That is the difference. So it does not require explicit declaration before you assign a value to it. Just assign a value to it, and then memory is allocated. So this equals to, this is not equals to, this is not equals to. In mathematics, this symbol is equals to, but in Python, this is assignment operator. So what this does is that is assigning this A on the left-hand side of this operator is the variable name, while this one is what? The value that you are assigning to the variable. So I can give another name as name, like this. This is a variable. And then I will say etete. So this is a variable. Name is a variable that I've created. And then I am assigning this etete to it as the parameter. So, and this is a name. So that is why I decided to choose name as the variable. So, but you cannot use the Python keywords, which is those words, those 35 keywords that I gave to you. You cannot use any of them to name a variable. It will throw you an error. So that is what this is. So I'm assigning a variable. So I've assigned that. When I execute it, now it has been assigned. Because I'm not calling a print function to display it on the screen, you are not going to see anything here. But it has been assigned. So a memory space has been allocated to this name, and there is an address for it. Another memory space has been allocated for this A, and there's an address for it. Now I can come here and find out the address of A and the address of name by calling my ID function. So ID, and then I'll supply A to it, and then I'll come here, ID, and I'll supply name to it. So I'm asking it to show me the address of A and the address of name. So when I execute this, it's done. So to display it on the screen, now, unlike when I was using the interactive mode, where I will have just typed ID and then this will appear. I have, for this script mode, I have to use my print function to bring it out. So I'm going to do this. A, then print this one will tell me the address of A, and this will tell me the address of name. Now I want to see it display on my screen. If I was using the interactive mode, just this alone will have shown me the address. But because I'm using the script mode, it means I have to use my print function to now supply this. So I'm saying, get me this address, and then print function, display it on the screen for me. So I'm using two functions here. I'm using the ID function to get the address of A. I'm using the ID function to get the address of name. And then I'm supplying that output to print function to display on the screen for me. So I'm just going to click on this. Now you can see it's displaying this, right? So this is the address of A. And then this is the address of of name. So this is how they are saved in the memory. When I add my comment, I can say this is an integer variable. This one, I will say this is a string variable. That is why I'm putting it in this single quote. These are integer variable, this is a string variable. That's why I'm putting it here. As we go on, I'm also going to, when we do data type, I'm going to show you how you know if this is an integer and if this is a string. There is a function you can call to that will tell you what type of data is in A and what type of data is in this variable name. Now I can print A and I can print name. So this now I can do this. See, to show me the address of A, show me the address of name, and then print what is inside A and print what is inside name. Show me on the screen. So that is just it. That is how you declare variable, you assign values to the variable, and you find the address of the variable and print out what is inside them. That is just what I did. So I decided to print out what is inside this variable here. Then I can delete this variable that I've created. Delete A. By calling this delete, so yeah, I can, this is it. I'll just click on delete. I want to delete A. I can just click on this, delete A, and then I will execute again. So now A is deleted. If I now say print A, look at what is going to happen. To give me an error. Look at error, name A is not defined because I deleted it. So that is how you delete a variable. Now, Python also allows you to initialize multiple variables in a single statement. For example, if I say A and I assign 20 to it, and then I come here, I say B, that is another variable. I assign 20 to it. Then I come here and I say C, I assign 20 to it. Now, when you look at this, the way Python variable works is different from the way a variable is declared in C language, for example. Now, in C language, assigning 20 to A, assigning 20 to B, and assigning 20 to C, how C language operates is that it's going to create 3 memory locations for each of these. So this A will be one memory location, this B will be another memory location, and this C will be another memory location. And each of these memory locations is going to have this value 20, 20, 20. But in Python, it is not so. In C, a variable is actually is an actual memory location. But in Python, it is pointing to the object. A variable is pointing to the object, not an actual memory location. So you have inside of the Python word, this A is pointing at 20 in the address, which is what? The physical location of memory. So there is an address in the memory, and then you have 20 inside it. When you declare a variable in Python, that variable is a pointer to the object, which is what? That 20, not to the memory location. It's not an actual memory location. So when I'm saying B, I'm assigning 20 again to B, assigning 20 again to C. It means that A, B, C are pointing at 20. They are not going to have 3 different memory locations in the memory. It's just one memory location. And then you are having this A, B, C pointed at it, at that one location. That is the difference with Python and other programming languages. So A is pointing at 20, B is pointing at 20, C is pointing at 20. So because of that, I can actually now say A equals to B equals to C equals to 20. I can do this. Right? I can do this. And then I can now say print. I can supply A, B, C. When I do this and I click on this, it's going to print it out 20, 20, 20. So Python allows me to declare this and then print. Now, if there are different values, say this one is 20, this one is 30, this one is 40, right? I can, in this case, I can do it this way. I can say A, comma, B, comma, C equals to 20, comma, 30, comma, 40. Just the same way they are. I can declare it this way. I can say A equals to, A is 20, B is 30, and C is 40. Then I can say print. It will print it out for me. 20, 30, 40. The same way. So Python allows me to declare variables in multiple variables in the same line, just like this. So I can do this, and then I'll print it out. When I say A, if I say A equals to 20, let me remove this. Now, A equals to 20, B equals to 20, right? A and B are pointing to 20. That is what I've explained to you. Now, when I change this place to say A is now equals to 30, it means the A will now be pointing to 30, but B will still be pointing to 20, right? Now, if I come here and I say print A, and I come here and I say print B, if I execute this, look at, it's telling me that, initially I assigned A 20 to A, and I assigned 20 to B. And here I now say A equals to 20. Okay, now to make you see that, let me do this one, print A. Look at this place. Python interpreter is going to interpret your query line by line. In this first one, A equals to 20. Now look at this. In this first one, A equals to 20. So I say print A, is going to print. Now it looks at this. He assigned 20 to A, which is a variable. And then I say print A, is going to print 20. Then it also assigned 20 to B. And in this place now, I now change the value of A by assigning A 30 to A. Meaning I'm now pointing A at 30. So I now say print A and print B. In this one, print B. When I do this again, look at the first one, printing A is going to print 20. Then it will look at this one, print B is also going to print 20. Now I say print A. When I reassign 30 to A, I now say print A is now going to print 30. And I say print B is still printing the 20. So B is still pointing at 20. Right? B is still pointing at 20. That is why it's still going to print out 20 here. But A is no longer pointing at 20, it's pointing at 30. So here it's going to print out 30. Now, when I come here and I now say B equals 40. Now, B is now pointing at 40. So if I say print, and I say print B, let's run this and see what it's going to give to us. So you can see the first one is print A, it printed out 20. Now, print B, it printed out 20 because both are pointing at 2020. When I say print A, after changing the value of A to 30, it's now printing 30, right? It's no longer printing, but B is still printing 20. Now, I change the value of B to 40, and I now say print B is now printing this, right? Now, if I come here and I say print ID and I supply 20 to it, it's still going to print the address of that. Now, when I do this, print, can you see it's printing the address for 10, meaning 10 is still existing. But if I say print ID and I supply A to it, and then I say print, I'm calling the ID and I supply B to it. Now, look at this. If I execute this, look at the address. There is an address for 30, which is A. And there is an address for 40, which is B. And there's also an address for 20. But there is no variable again pointing at 20 because I'm actually now pointing A to 30 and I'm pointing B to 40. There is no variable again pointing at 20, but there is still 20 existing because there is a memory location for 20. There is still 20 existing, right? Now, what will happen is 20 is now standing alone. Nobody is pointing at it again. No variable is pointing at it. Now, in Python world, there's what we call the garbage collector. So the garbage collector is one that will now come and wipe out this 20 because there is no variable pointing at it. So Python will not allow, the Python interpreter will now say, okay, since there's no variable pointing at this 20, the garbage collector should now go and clean up that memory space so that it can now be reassigned to somebody else. That is actually what happens. So the same way your physical world is running, that you have the garbage collectors that come and take out your garbage. Same way now in Python, there's a garbage collector that will now go to that memory location and clean up that variable. So the next class now, we are going to look at data type, like the 10, A equals to 10 that I gave you, and even this data that you are looking at that is applied to this variable. Now, what kind of data is this? This is a string. So in the next class, we are going to look at data type that you supply to individual variables. So I will see you in the next class. Till then, bye-bye.